Download this code from codegive.com, link in the description below. Compressing Web API Post Requests, a comprehensive guide. This tutorial provides a comprehensive guide on compressing Web API Post Requests in C, covering the benefits, techniques, implementation, and best practices. Compressing data, especially in post requests, can significantly improve performance by reducing bandwidth consumption, decreasing latency, and optimizing resource utilization. This is crucial for applications handling large payloads, operating in bandwidth-constrained environments, or aiming for a better user experience. Why compress post requests? Reduced bandwidth consumption. Compressed data requires less bandwidth to transmit, lowering transfer costs and improving network efficiency. Faster transmission. Smaller payloads translate to faster transmission times, resulting in quicker response times for clients and a more responsive application. Improved scalability. Reduced bandwidth usage allows the server to handle more requests concurrently, improving overall scalability. Enhanced user experience. Faster response times directly contribute to a better and more satisfying user experience. Lower network latency. Smaller payloads are less susceptible to network latency, leading to more consistent performance. Techniques for compression. The most common and widely supported compression algorithms for Web API post requests are zip, GNU-zip, a popular lossless data compression algorithm. It's efficient and well supported by most browsers and servers. It usually provides a good compression ratio for text-based data like JSON and XML. Deflate. Another lossless data compression algorithm, similar to GZIP, but typically used in .NET environments. GZIP is generally preferred because of broader support. .li. A modern compression algorithm that often outperforms GZIP and Deflate in compression ratio, especially for text. However, client and server-side support is more recent than GZIP. For Web API scenarios, GZIP is generally a good starting point. Consider .li if you need the best possible compression and you can ensure both the client and server support it. Implementation in C Web API. Here's a breakdown of how to implement GZIP compression in your C Web API. 1. Server-side implementation, Web API. Install Microsoft.ASP.NET.WebAPI.Client and System.io.Compression NuGet packages Create a custom action filter attribute This is the recommended way to compress responses dynamically based on client requests. This filter will intercept the response before it's sent and compress it if the client indicates it accepts GZIP. Apply the attribute to your Web API controller or action Alternatively, you can register it globally in Web API config.cs. Explanation The compress attribute intercepts the response after the action method executes. It checks if the client's accept encoding header indicates support for GZIP compression, or .li if you choose to implement it. If GZIP is supported, it reads the response content as a byte array. It compresses the byte array using gzip stream. It creates a new byte array content with the compressed data. It copies the original content headers to the new content, important for preserving content type, etc. Crucially, it removes the original content length header and adds a content encoding header with the value GZIP. The content length header must be removed because the compressed data has a different length than the original data. Browsers will use chunk transfer encoding when the content length is not provided. It sets the response's content to the compressed content. 2. Client-side implementation, see example. Asterisk set the accept encoding header asterisk. Explanation asterisk. Asterisk serialize and compress asterisk. The client serializes the data to JSON and then compresses it using gzip stream. Asterisk content encoding header asterisk. It adds the content encoding zip header to the request to indicate that the request body is zip compressed. Asterisk accept encoding header asterisk sets the accept encoding header to zip to tell the server that the client can accept zip compressed responses. This is crucial. Asterisk decompression asterisk. The client checks the content encoding header of the response. If it's zip, it decompresses the response stream using gzip stream before reading the content. 3. Client-side implementation, JavaScript/fetch API example. Explanation asterisk. Asterisk compression library asterisk. JavaScript doesn't have built-in zip functionality. You'll need a library like Payco, a popular and efficient zip library, or use the browser's experimental compression stream API if supported, see notes below. Install Payco using npm or yarn, npm install Payco or yarn add Payco. Asterisk serialize and compress asterisk. The JavaScript code serializes the data to JSON and then compresses it using Payco.zip. Asterisk headers asterisk. It sets the content encoding zip header in the request to tell the server the body is compressed. It also sets accept encoding zip to tell the server it can accept a compressed response. Asterisk decompression asterisk. The code checks the content encoding header of the response. If it's zip, it decompresses the response using Payco.unzip, or Payco.inflate, if you expect a uint8 array. Asterisk error handling asterisk includes basic error handling for fetch operations. Using browser's native compression stream, experimental. Some modern browsers support the compression stream and decompression stream APIs, but they are still experimental. If you want to use them, be aware of potential browser compatibility issues and polyfill requirements. Here's how you might use them. Replace the Payco parts in the JavaScript example above. Remember that compression stream is experimental and may require polyfills for older browsers. 4. Server-side .li compression, Web API. You can implement .li compression similarly to zip. Asterisk install NuGet package asterisk. Asterisk modify the compress attribute, or create a new .li compress attribute. Asterisk apply the .li compress attribute to your controllers or actions. Asterisk client-side .li support asterisk. Your client, C or JavaScript, will need to be able to decompress .li encoded responses. This means using a .li decompression library, example .li sharplib in C or a JavaScript .li library. The JavaScript example will be similar to the zip example, but uses Payco.inflate. If it supports .li, you might need a separate .li library, instead of Payco.unzip. Important considerations and best practices asterisk. Asterisk HTTPS asterisk. Always use HTTPS when compressing data. Compressing unencrypted data over HTTP makes your application vulnerable to security exploits like breach. Breach exploits the predictable patterns that compression can introduce into HTTP responses to extract sensitive information. HTTPS encrypts the data before compression, mitigating this risk. Asterisk content length asterisk. Remove the original content length header. The compressed data will have a different length. The server, or client, should not send the original, uncompressed content length. Removing it allows the HTTP protocol to handle the length automatically, often using chunk transfer encoding. Asterisk content type asterisk. Preserve the original content type header. This tells the client what kind of data it's receiving, example application/JSON. The compression doesn't change the type of data, it only changes how it's encoded. Accept encoding the server should only compress the response if the client includes an accept encoding header indicating support for the chosen compression algorithm, zip, .li, etc. Client-side decompression ensure that the client, browser, C application, etc., is able to decompress the data using the appropriate algorithm. Compression level compression algorithms often have different levels of compression, example zip has levels from 1 to 9. Higher compression levels result in smaller files but require more CPU resources. Experiment to find the optimal balance between compression ratio and performance. The default compression level is often a good starting point. Static content for static content, example JavaScript files, CSS files, images, it's more efficient to pre-compress them and serve the compressed versions directly from your web server, example IIS or Apache. This avoids the overhead of dynamic compression on every request. Configure your web server to serve pre-compressed files with the appropriate content encoding header. Testing thoroughly test your implementation to ensure that compression is working correctly and that your application is still functioning as expected. Use browser developer tools or network analysis tools to verify that the content encoding header is being set correctly and that data is being transmitted in compressed form. Monitoring monitor your server's CPU usage and network bandwidth to assess the impact of compression on performance. Caching make sure your caching mechanisms are compatible with compression. If you're caching compressed responses, ensure that the very header includes accept encoding so that the cache correctly serves different compressed versions based on the client's capabilities. Example of setting very header *. Large payloads compression is particularly beneficial for large payloads. For small payloads, the overhead of compression and decompression might outweigh the benefits. Exceptions and error handling include robust error handling in both your server-side and client-side code to gracefully handle any exceptions that might occur during compression or decompression. Log errors appropriately. .li versus xip while .li often offers better compression ratios than xip, consider the trade-offs. .li has more recent browser support than xip. Xip is generally a safer choice if you need to support a wider range of older browsers. If you're targeting modern browsers, .li can provide a significant performance improvement. Dynamic content versus static content. Dynamic content, example responses generated by your web API, benefits greatly from dynamic compression as described in this tutorial. Static content, example images, CSS, JavaScript files, is usually better pre-compressed and served directly by the web server. Middlewares and modules. Frameworks like ASP.NET Core often provide built-in middleware components for compression. Explore these options, as they may simplify the implementation process. Conclusion: compressing web API POST requests is a powerful technique for optimizing performance, reducing bandwidth consumption, and improving the user experience. By following the steps outlined in this tutorial and carefully considering the important considerations, you can effectively implement compression in your C Web API and reap the benefits of a more efficient and responsive application. Always remember to use HTTPS to protect your data and thoroughly test your implementation to ensure everything is working correctly. Remember to tailor your solution to your specific needs and the capabilities of your clients and servers.